So, bali yun, kami yung group 1 and yung report namin is about sa metal and steel manufacturing process as well as yung glass process. So, for this, pa-next ako lang. So, in table of contents namin, first we have the history and introduction of steel process. 2, we have the common terminologies used in steel manufacturing. 3rd, we have the metal cutting or different types of metal cutting. 4 is the metallurgy. And next link. Number 5, we have the manufacturing process. Number 6, we have the welding fundamentals or the basics of welding fundamentals. 7, also yung mga links sa YouTubes na ginamit namin. And last one would be the references. So we need to properly credit yung mga ginamit natin na sources. So sa introduction and sa terminology, si Iling po yung mag-start.
For the introduction and history, in this section, we are going to learn about the history of steel and metal manufacturing. First is that the earliest the copper pendant is the oldest known material metal. Known industrial metal, mining and working operation has been dated to the discovery of copper pendant in the northern Iraq from about 8700 BCE. Next is the tools and weapons. Iron, silver, and gold. These advanced tools made by early civilization by utilizing the metals from ores such as iron, silver, and gold. And the steam-operated rolling mills. During the Industrial Revolution, wherein the steam is the main driving component for engines, it was utilized to retrofit manually operated machinery such as rolling mills for easier production. Next is the manually operated rolling mills. The idea of Leonardo da Vinci about rolling press brought about the beginning of metal sheets. In 17th century, the rolling mills for making metal sheets are manually operated. And aside from rolling the metals, there are many more types of forming metals that are developed throughout the years. It includes forging, wire drawing, extrusion, deep drawing, stretch forming, bending, and shearing. Next is the common terminologies used for metal manufacturing and processes. The American Iron and Steel Institute, or also known as AISI, the American Iron and Steel Institute, AISI, it is the leading institute where the basis of metals are made based on their research and studies. Next is the alloying element. Alloying element is any metallic element added during the melting of steel or aluminum for the purpose of increasing corrosion, resistance, hardness, or strength. Next is the annealing. Annealing, a thermal treatment process by which a previously cold rolled steel coil is made suitable for forming and bending. The steel sheet is heated to a designated temperature for a sufficient amount of time and then cooled. Next is the blast furnace. A towering cylinder lined with heat-resistant or refractory bricks used by integrated steel mills to smelt iron from iron ore. Its name comes from the blast of hot air and gases forced up through the iron ore, coke, and limestone that load the furnace. Casting. The process of pouring molten metal into mold so that the cooled solid metal retains the shape of the mold. Cladding. Cladding is the method of applying a stainless steel coating to carbon steel or lower alloy steel. Example, steel with alloying element content below 5%. Deburring. The process used to smooth the sharp jagged edge of cut piece of steel. Descaling. The process of removing scale from the surface of steel. Scale forms most readily when the steel is hot by union oxygen with iron. And ductility, ability of steel to undergo permanent changes in shape without fracture at room temperature. And flux, an iron cleaning agent. Limestone and lime react with impurities within the metallic pool to form a slag that floats to the top of the relatively heavier and now more pure liquid iron. And hardening. Hardening is the process that increases the hardness of steel. Example, the degree to which steel will resist cutting, abrasion, penetration, bending, and stretching. And machining refers to performing multiple processes to a piece of metal to produce a customer-satisfied component part. And pellets, a fine particle of iron or mixed with bonding clay and roasted into hard round balls for blast furnace feed. Statistical process, a technique to predict when a steelmaking function's quality may deteriorate. By monitoring the product variance, the operator can determine when to apply preventive maintenance to a machine before any low-quality secondary steel is produced. Tolerances, a customer specification can refer to the dimensions or the chemical properties of steel ordered. The tolerance measures the allowable difference in product specification between what a customer orders and what the steel company delivers. And next is the metal cutting, and will be reported by my groupmate Zoren.
So good morning po sir and everyone. So I'm Zoren Arcilla po and I will be reporting the third and fourth chapter po, yung metal cutting and metallurgy. So for first the metal cutting. For metal cutting, metal fabrication is an essential step in creating all sorts of metal parts, components, and machines. During almost any fabrication process, the metal materials required will need to be cut. However, there are several different types of metal cutting approaches you can choose from, such as grinding, drilling, turning, water jet, plasma, and laser. So first, for the grinding, it is a metal cutting process that is used in a fabrication. The actual metal grinding is used to rid metal components of rough edges by deburring, smoothing out welds, and in some cases, creating sharp edges. So next is for the drilling. It is another important action for metal fabrication and used to create holes of precise specifications in a metal component or surfaces. The hole itself is created by applying pressure and rotation on top of the metal component or surface. Next slide. So for the turning, or also known as the metal spinning, the metal turning is a metalworking process wherein a tube or disc rotates at a high speed to help from metal in the desired configuration. The turning process is typically conducted by hand or through use of lathe. So next is the water jet. The water jet process includes mixing water with metal abrasive and then applying it a high force to the metal component that needs forming. The water jet approach allows for precise metal surface during the fabrication process. For plasma, it is one of the newer approaches to the metal cutting. The fabricators uses plasma torches that pass an electrical arc through oxygen or a different inert gas. This electrical arc simultaneously blows away unwanted molten metal and melts away the metal surface that forms and shaping. So next is the laser. For the utmost in precision and control, we choose laser metal cutting technology for the application. So during the laser cutting process, a highly concentrated light beam at a higher temperature is used to cut a component to specific shapes and sizes. So for the next part is the metallurgy, in which different types of pressure metallurgy are used in the industry. So first, let's discuss what is metallurgy. It is defined as a process that is used for the extraction of metals in their pure form, from which the compounds of materials are mixed with oil, limestone, sand, and rocks, na kung saan tinatawag yun na minerals. So there are three classification of metallurgy. So first is the physical. It is the science of making useful products out of metals. So metal parts can be made in variety of ways depending on the shape, properties, and the cost desired in the finished product. So the second one is the extractive, from which the practice of removing valuable metals from an ore and refining the extracted metals or materials into a pure form. So the last is the mechanical, from which the area of metallurgy concerned primarily with the response of metal to forces or loads. Forces may arise from the use of the metals as a member or part in a structure or machine. For the physical metallurgy, it is concerned with the physical and mechanical properties of metal as affected by composition, mechanical working, and heat treatment. So this includes the following processes such as casting or molding, forging, welding or soldering, heat treatments, cutting or machining. So it is involved anything that is concerned with the physical characteristic of metals that can be included here. For the extractive metallurgy, it deals with the processing of the natural occurring raw materials for converting those into those into useful metals and alloys. So the three main ways to extract are the hydrometallurgy, electrometallurgy, and pyrometallurgy. So for the hydrometallurgy, it uses the wet methods, usually conducted at ambient condition but also sometimes at the boiling point of solution and under pressure. For the electrometallurgy, it is the processes based on the use of electric current for affecting a chemical transformation for metal recovery or refining. And for the last is for the pyrometallurgy, from which it uses dry methods, usually conducted at high temperature and may involve melting of the charge. For the mechanical metallurgy, it is the area of metallurgy from which it is concerned primarily with the response of metal to forces or loads. The forces may arise from the use of the metals as a member or part in a structure or machine, in which case it is necessary to know sometimes about limiting values which can be withstood without failure. So, yung mga example po niyan, yung mga pictures above for, yan po yung mga metals under load. So, the next part will be reported by my fellow member, Albert Chua.
Wait lang, prepare ko lang po. Ayun. So for manufacturing process, we have the manufacturing process for steel or metal production. So the first one would be what is the steel production process? So kung makikita niyo sa picture, meron tayong iron ore, meron tayong wait lang. Meron tayong iron ore and scrap metal. Tapos ito yung process yung sa mining. Ito yung mga equipments nila. So, ano ba yung idea behind this steel production process? So, of course, mag-start muna tayo sa raw materials kung saan ginagather siya sa mining industry natin, sa mga mining sa mga mining areas natin. And then after that, gagamitin natin yun para ma-extract yung purer form ng mga ores na yun. So, for example, iron ore, ano ba yung mas pure form niya, which is iron. So, doon papasok yung sinasabi ni Zoran kanina, which is the extractive metallurgy. So, before tayo mag-start sa actual process, let me introduce first the different parts of the steel production process. For the first one, we have the raw materials such as iron ore, limestone, coal, and scrap metals. So, generally, ito yung mga ginagamit natin na raw materials for the steel production process. So, ang ginagamit dito is iron ore and limestone. So, basically, yun. Yung mga main components. While the scrap metals also we also use scrap metals for the production of steel. Mamaya explain ko kung saan siya ginagamit. So, as I mentioned earlier, ginagamit natin yung extractive metallurgy, which is the blast furnace, another form ng extractive metallurgy, para makuha natin yung mas valuable form ng iron or yung mga ores or limestone. After natin makuha siya from the mining areas, ginaground to into a finer particles. So, kasi syempre pag nakuha natin siya sa mine, medyo malalaki pa yung particles niya or yung sizes niya. So, ginagrind natin yun or ginaground natin yun para mapunta siya yung susunod na part natin, which is the sinter plants. The sinter plants, yung purpose niya is to agglomerate yung mga fine particles na yun or yung fine materials na yun such as iron ore or the limestone at high temperature. So, kung hindi kayo familiar sa sinter, ang itsura niya is parang namuo siya o kumbaga nagka-clump, which is yung term is to agglomerate. So, yung clump doon, may mixture na siya ng iron doon and then yung mga limestones and other minerals. So after ng sinter plants, pupunta tayo sa coke ovens. Itong coke oven, another area naman to. Dito pumapasok yung mga coals na nakuha natin. So papainitin natin yung coals na to. We're heating up at up to 1,000 degrees Celsius. So ito kasi yung i-feed natin sa blast furnace natin mamaya. And ito yung tumutulong din para matunaw or ma-melt natin yung smelting process ng iron ore natin or yung sinter natin. Ito yung blast furnace, kanina sinasabi ko. Yung blast furnace, ito yung responsible para ma-separate natin yung mga minerals or makuha natin yung pure iron metals from the sinter. So yung smelting furnace, ito yun, parang malaking tower siya.
So, dalawa yung lumalabas sa kanya dito. I mean, dalawa yung naproproduce na product, which is pig iron and slag. So, in terms of usability, mas ginagamit natin yung pig iron kasi ito yung mas naproproduce natin yung working steel. However, yung slag naman parang more of a waste type. Pero actually hindi siya waste kasi ginagamit din siya into other forms such as sa mga pavements, sa mga highways. So ginagamit din yung slugs and other applications. Pero mostly ang ginagamit natin into steel is the pig iron. So may papanood ako sa inyong video with regards to the blast furnace.
Extraction of iron. It has been since 5,000 years that man is using iron. Iron is the second most abundant metal in the earth. The most important ores of iron are hematite and magnetite. These ores contain different types of impurities. The first step is to remove the impurities. This is called as concentration of the ore. The iron ore is converted to iron in a blast furnace. This is made of steel in which the inner side is covered using bricks. The mixture of concentrated ore, coke and limestone are added from the top into the blast furnace. A powerful current of hot air is blown from the bottom simultaneously. During the flow of hot air from bottom to top, coke combines with oxygen in the air to form carbon monoxide. 2C on reaction with O2 forms 2CO. Due to this reaction, large amount of heat is released and thus the temperature of blast furnace increases to 2000 degrees Celsius. Carbon monoxide formed in the furnace reduces the ore. Fe2O3 on reaction with 3CO forms 2Fe and 3CO2. At high temperature, calcium carbonate decomposes to form calcium oxide and carbon dioxide. CaCO3 forms CaO and CO2. Then impurities silicon dioxide in the ore reacts with calcium oxide and form calcium silicate, which is known as slag. Flux on reaction with GANCH forms slag. CaO on reaction with SiO2 forms CaSiO3. The iron obtained directly from blast furnace is called as pig iron. It contains carbon, sulfur, phosphorus, manganese, silicon, etc. in very small quantities. Pig iron is heated to melting and again solidified to get cast iron. In cast iron, 95% is iron. The iron which contains 0.1% to 1.5% of carbon is called steel.
So yun yung about sa blast furnace. Next one, we have the basic oxygen furnace. So ito yung furnace, itong basic oxygen furnace na to. Ito yung ginagamit natin para tunawin uli yung pig iron or kumbaga tanggalin pa natin yung ibang impurities. So paano ba nag-work? Ano ba yung main principle behind the basic oxygen furnace? So yung principle dito is that pinapainitan natin ulit yung hot metal na to. And then at the same time, papasukan natin to ng oxygen. So yung oxygen at saka yung carbon, kasi di ba dissolved na yung metal or liquid form yung metal. So nagre-release ng carbon yun. Yung metal, may dissolved carbon tayo doon. So kapag pumasok yung oxygen doon, magkakaroon tayo ng chemical reaction in which magpo-form ng carbon monoxide. So dahil doon, nare-release yung carbon sa loob ng metal natin. Ibig sabihin natatanggal. Kaya yung usok na makikita nyo, yun yung carbon monoxide usually. So nababawasan yung carbon content natin sa metal, sa hot metal natin para mas maging pure to. Kasi if you remember sa lesson natin sa material science and engineering, removing carbon content or lessening the carbon content in irons or steel, or kapag mataas yung carbon content rather, mas brittle yung magiging steel natin, mas mababa yung tensile strength, yung resistance mababago din. So lahat yan maaapektuhan kapag mataas yung carbon content natin. So that's the purpose of the basic oxygen furnace. Binabawasan natin yung carbon content para mas gumanda yung features or mas gumanda yung ductility or yung tensile strength natin tumaas. So yun yung reason kung bakit dumadaan tayo sa basic oxygen furnace. Another furnace would be the electric arc furnace. So yung electric arc furnace naman, basically ito yung mas efficient na basic oxygen furnace kasi hindi tayo gumagamit ng fuels dito. Ang ginagamit natin dito is from the word itself, electric. So usually ginagamit natin yung electric arc furnace kapag scrap metals yung ginagamit natin. So hindi natin siya masyadong ginagamit kapag yung minerals yung ilalagay natin siya. So most commonly ginagamit siya kapag mga scrap metals lang. So after that, we were going to the ladle refining furnace. So another furnace na naman to para matanggal yung mga impurities natin. So it is used to desulfurize the steel. So if you remember, sulfur is another impurity. So yung ladle na to, from the word itself, ladle, para siyang lagayan. Kasi dito na ilalagay yung hot metals natin onto the next process, which will be the continuous casting. So dun siya ibubuhos. So yung continuous casting from the ladle refining furnace, papadaanin natin siya sa mold, which is a series of die kung saan nandun na nakasukat yung sizes nung gagamitin natin or yung semi-finished products natin. So ito yung sample ng continuous casting. Yung mga semi-finished products natin would includes the blooms. Kung makikita nyo blooms, ito ginagamit usually to sa mga steel sections. Kung makikita nyo yung mga beams natin, yung mga sections, dito lang gagaling yun sa mga blooms. Another one would be the belays. Ito yung mga round bars tsaka yung mga square bars. Kung maalala nyo sa workshop natin, yung rod, yung ginamit natin, yung aluminum rod. So, dito galing yon sa belays. Slabs naman, ito yung ginagamit para sa mga metal sheets, sa mga plates. Ito yung niro-roll, dumadaan sa rolling mills para ma-produce as sheets ito. Sheets, coils, and strip plates. So, after that, dadaan ulit tayo sa furnace reheat. So, ano bang purpose ng furnace reheat natin? Again, sa material science and engineering natin. That is to increase yung tensile strength, again, yung ductility ng materials kasi pinapainitan natin siya para mag-harden lalo, mas mag-combine yung mga composition niya. So, ito. Pinapainitan natin siya around 1,200 degrees C, which is suitable for plastic deformation of steel and hence for the rolling in mill. Para mas maano kasi natin siya. Kasi after ng furnace reheat natin, dadaan siya sa rolling mills para mas madali siyang ma-form. So ito. Rolling mills is a machine that reduces the thickness of metal without sacrificing any material. Meaning, material is always displaced and never lost. By design and function, rolling mills do not generate scrap. After dumaan ng rolling mills, meron na tayong mga finished products such as yung rolled steel natin, ng mga plates, yung plate natin, we have the tubes, We have the sections, yung sinasabi ko kanina, from blooms, galing to sa blooms. Rods and bars, as well as the decking. So ito usually ginagamit natin sa bubong or yung tinatawag nating yero. So ito yung general process. Kung makikita nyo, ito yung raw materials natin from iron or limestone. Dadaan siya ng sinter plant. So ito yung magka-clamp kanina. Yung coal naman, dadaan sa coke ovens. And then yung scrap metal natin, as I mentioned earlier, diretso siya sa electric arc furnace. So from sinter plants at saka yung coal, yung tatlong yan, dadaan dito sa blast furnace natin para ma-produce yung pig iron. And after that, pupunta tayo sa basic oxygen furnace natin, which is another form ng pagtanggal ng carbon natin. And then from there, dadaan tayo ng ladle refining para matanggal pa yung mga impurities. And then sa continuous casting naman tayo para ma-achieve natin yung desired shape na kailangan ng manufacturer. So ito yung mga semi-finished products natin, blooms, billets, and slabs. Then dadaan tayo ng furnace reheat para ma-achieve natin yung plastic deformation and then mas madali nating ma-form kapag dumaan ng rolling mills. So after going to the rolling mills, ma-produce na natin yung mga products natin such as the plates, hot rolled, yung welded tubes, light gauge decking, sections, and rods and bars. So meron akong video regarding sa steel production.
Duisburg is the largest steel production site in Europe. Our iron and steel mill is like a giant machine. We produce flat carbon steel here around the clock, 365 days a year. This requires iron ore, coal and other raw materials delivered by ship or rail. The coal first enters the coking plant and is baked at a high temperature for 25 hours. The resulting coke is cooled down with water until it is hard and porous, just right for the blast furnace. In the sintering plant, fine iron ore is prepared for further processing in the blast furnace. Extremely hot air is used to cake the iron ore into coarse lumps in the sintering process. Now the smelting can begin. Iron ore, coke and additives are continuously filled into the blast furnace from above, up to 25,000 tons of material per day. Hot air at 1,250 degrees Celsius is blown in from below. This leads to complex reactions at high temperatures. The oxygen is removed and the ore is reduced. As they melt, the various components move steadily downwards, resulting in molten pig iron and slag. In the tapping process, the finished pig iron and slag are discharged from the blast furnace every 2 to 3 hours at a temperature of 1,500 degrees Celsius. The actual steel is produced in the melt shop. To make flexible, forgeable steel from the brittle pig iron, the amount of carbon must be reduced. This is done in a converter. Steel scrap is mixed into the molten pig iron. This environmentally friendly process is used for cooling. Oxygen is then blown in, which reduces the amount of carbon and results in crude steel. Not all steel is the same. Secondary metallurgy allows the chemical composition of the molten steel to be controlled with great precision. The steel is boiled with small amounts of chromium, molybdenum, or other additives to form an alloy. This process is used to produce some 2,500 different grades of steel. And every year, we develop new materials and research different applications for steel. How is sheet formed from molten steel? There are two options: the casting rolling line and the continuous caster. In the casting rolling line, the steel is cast into a thin strand that can be rolled directly to strip. The steel strip is wound into a coil that weighs up to 45 tons. continuous caster produces thick slabs. These are massive blocks of steel that can be subsequently rolled into sheet and plate in the hot strip mill. The plate mill transforms the slabs into steel plates with a thickness of up to 18 centimeters. These heavy plates are used for large cranes and other heavy-duty machinery. The hot strip mill produces thinner steel. A red-hot steel strand is reduced to a thickness of a few millimeters by powerful rollers. At the end of the nearly 500-meter-long production line, the steel strip is wound into a coil and can be sold as hot strip. The cold rolling mill is where even thinner materials are produced. Before processing, the scale is removed from the steel strip in a pickling line. Afterwards, the steel strip is rolled down to thicknesses of less than 1 millimeter. Precisely defined mechanical properties are achieved by special rolling processes, along with selective heating and cooling of the steel. Hot dip galvanizing protects against rust. This is especially helpful for car manufacturers. In the hot dip coating line, the steel strip is heated and dipped into a bath of liquid zinc. The protective zinc permanently bonds to the surface of the steel. Other finishes can be applied to the steel in the coil coating line. Paint, films and other coatings ensure that the sheets can be processed immediately into finished products. For example, for building facade construction or the household appliance industry. Heavy plate, hot rolled and cold rolled strip, uncoated, coated, hot dip and coil coated. We supply a wide range of steel products. Working together with our customers, we develop innovative solutions for their business needs. Other plant sites are supplied with starting material, for example, to manufacture packaging.
So yun yung regarding sa steel production natin. Another part ng yung gustong ipasama ni Sir Inaw sa akin is yung basics or yung fundamentals ng welding. So, ano ba yung welding? So, welding is a materials joining process in which two or more parts are coalesce at their contacting surfaces by a suitable application of heat and or pressure. So, I know familiar naman kayo sa welding kasi sa time ni Sir Tadike sa workshop natin, nakapag-welding tayo. So meron tayong two types ng welding. Basically yung fusion and yung solid state welding. Sa fusion welding, usually dito tayo gumagamit ng mga filler metals or yung mga welding rods. For the solid state naman, we're using heat and pressure. Usually wala tayong ginagamit na filler metals dito. We rely only on the heat and pressure or the friction of the materials. So the next one would be for the fusion welding, we have three categories under fusion welding. First one is the arc welding. So ito yung most common na ginagamit natin. Ito yung gumagamit tayo ng welding rod or filler metals. Nakakonekta sa welding unit natin. Yung resistance welding naman, I'm sure familiar kayo dito, nakikita nyo sa mga Facebook, sa feeds. Ito yung may two metals na merong dumadaang na electric current. And then kapag nagdikit sila, magkakaroon tayo ng etong part na to. Magbe-melt yan. And then yung end product yan would be welded na sila. Yung oxy-fuel gas naman, or mas familiar kayo sa acetylene, ito yung gumagamit ng acetylene mixture to produce hot flame for melting the base metal and the filler metal. So, yun yun. For the solid state welding naman, no filler metal is utilized. And under solid state welding, we have the diffusion welding, in which under pressure yung metal natin at elevated temperature also. So doon nangyayari yung diffusion natin, yung solid state diffusion natin, in which magko-combine or magsasama yung dalawang metals natin. For the friction welding, ito naman, kung makikita nyo, itong part na to kasi, ito yung sa mga YouTube videos natin or sa mga Facebook. Yung dalawang parts na to, or dalawang metals na to, naging ganito dahil sa friction. So wala tayong ginamit na filler metal dito. Ang ginamit natin dito is machines or yung friction natin hanggang sa uminit siya and then mag-dissolve and then doon natin i-combine. Kasi pag nag-solidify to, basically welded na sila. And then yung ultrasonic welding naman, basically parang friction welding lang siya. Ang ginagamit lang natin is ultrasonic frequencies para mag-combine or ma-weld yung dalawang metals natin. So for the type of joints, we have 5. The butt joint, edge, lap, T, and the corner joint. So kapag butt joint, ang gina-join natin, yung dalawang end ng metals natin, doon natin siya i-weld. So ito yun, itong part na to. Butt joint yung tawag dito. Kapag edge joint naman, meron tayong magkadikit na metals or in parallel sila. Tapos yung edge nila, yung common edge nila, doon natin siya i-weld. So ito. Sa lap joint naman, meron tayong ito, from the word itself, overlapping sila. So yung overlapping nila, doon natin siya i-weld. Kung makikita nyo dito. Itong part na to at saka yung other one. Sa T-joint naman, from the word itself, nagre-resemble siya sa letter T, perpendicular to the other metals or the other base metal natin. So yung dalawang gilid niya, doon natin siya i-weld. Itong part na to at saka yung other side. Sa corner joint naman, usually nag-form siya ng 90 degrees or at any angle. And then yung space between doon sa kanila, yun yung i-weld natin. Kung makikita nyo dito. Ayan. So yun yung mga basic types of joints natin. Yung basic types of welds naman, we have the flash. Usually yung ginagamit dito is electric current between two surfaces. Yung kanina, yung parang natin, yung na-mention natin kanina. So ito yun, yung flash weld yung tawag natin. Yung spot weld naman, yung na-mention ko kanina, yung may dumadaang electrical resistance into two prongs or two sticks. Spot yung tawag doon, spot welding. For seam naman, ito kung makikita nyo, meron parang bilog dyan. Usually ginagamit ito pang enclose ng mga metals or mga sheet metals natin para ma-enclose siya. Seam welding yung ginagamit natin dito. Also electric current and pressure yung ginagamit sa kanya. For fillet naman, it refers to the process of joining two pieces of metals when they are perpendicular or at an angle. Basically, ito yung tinatawag natin na corner joint, yung fillet. So another type of weld would be the groove. Itong groove na to, meron siyang predefined na groove, yung parang uka. And then from there, doon natin siya i-weld. So ayan, the example. Surfacing naman, these are welds composed of one or more strings with beads deposited on an unbroken surface to obtain desired properties or dimensions. So ito yung surfacing natin. The plug weld naman, may mga butas siya. And then yung butas na yun, i-weld natin siya doon sa another metal natin. Usually ginagamit to sa overlapping joints. Yung plug weld. The last one would be the slot weld. Slot weld, wini-weld natin siya kapag meron tayong elongated hole doon sa two pieces of metal natin. So katulad nito, meron siyang hole and then from there, doon natin siya i-weld. So for the American Welding Society or yung AWS natin, it was founded in 1919 as a non-profit organization with a global mission advancing the science, technology, and application of welding and allied joining and cutting processes, including brazing, soldering, and thermal spraying. So when it comes to welding, ang pinagbabasihan natin lagi doon is the AWS or the American Welding Society. And meron tayong tinatawag na AWS number system or the American Welding Society numbering system. that can tell the welder quite a bit about specific stick or electrode, including what application it works best and how it should be used to maximize the performance. So kung familiar kayo sa ginagamit natin na welding rod or yung electrode natin, merong mga nakasulat doon na numbers, and yun yung tinatawag natin na AWS number system. So from there, malalaman natin kung saan ba sila applicable or saan sila pwedeng gamitin, paano yung position ng paggamit sa kanila, ano yung coating, and ano yung current na pwedeng mag-work sa kanila. So for example, ito, meron tayong E6010. Yung E corresponds with the electrode. Yung 60 correspond to the tensile strength. So kapag 60 yan, equivalent yan sa 60,000 PSI. Yung position naman, meron tayo mamaya, ipapakita ko kung ano yung iba't ibang position. Kapag position ng number 1, that is all position yan. Sa coating and current naman, 0, meron din tayong nagko-correspond dito na type ng coating at saka yung current na dumadaloy sa kanya. So ito. For number 1, kapag number 1 yung nakalagay, all position yung electrode natin. Kapag 2, pwede lang siyang flat and horizontal. Kapag 3 naman, flat lang yung pwede niyang yung position na pwede sa kanya. Kapag 4 naman, flat, horizontal, vertical, and overhead. For coating and current naman, ito yung mga designated niya. Yung 0, yung high cellulose sodium, ang papasok sa kanya na current is DC+. So ito yun. Ito yung iba't iba. Galing to sa AWS numbering system. Ito yung designation nila. So meron akong present dito na most common electrodes. Yung E6010, E6011, E6013, E7018, and E7024. So ito yung mga most common electrodes na ginagamit ng mga welders natin. So lahat ng diniscuss sa inyo ngayon, I mean yung mga welding processes, yung manufacturing processes, and the metal cuttings, lahat yun pa makikita natin sa internet or sa YouTube ni Sir Inaw. So most common electrode, so ito yan. Ito yung mga links sa YouTube videos. Basically, nandito yung mga videos na ginamit namin in the course of the report. So most of it galing sa Charlton Academy. Yun, so that's one with the references. So yun lang. Thank you. Next pala yung yung glass manufacturing na.